Evening, welcome to Land Tamer Stream. It is Wednesday and we are working on some OSPF PE CE routing. That is what we're going to do today. So I'm back yesterday. I was finishing watching some videos just to give you an update on that. So if I go and look at the INE videos, and yes, it was INE this time. Trying to continue along those lines. I did... Yeah, PE CE routing with ERGRP and PE CE routing with OSPF, which is a long video. It's a gig low and high def compared to a lot of these other sizes. Then we got coming up later is BGP multipath, and prefix independent convergence. So 3 videos left after this. So we're getting near the end of this MPLS section, which is good. But let me bring up the agenda for today. For today's stream. Hope everybody's having a good Wednesday. Hope the bits are going where you need them to go. Pull up the chat window here. And the agenda, of course. I'm calling this a cruel OSPF PE CE lab. And I'm going to explain why. But yes, to me it is harsh, cruel, mean. And I will explain that. But that's what we're going to attempt to do today, the lab we're going to do today. We did PE CE routing with RIP, but this today is slated to continue with next protocol, which is OSPF. Just to discuss another find I had, this was actually mentioned by Brian McGann in his video. I have been reading MPLS fundamentals in Safari Books Online. And I actually found that there was quite a bit of older material in there. Essentially, the story was kind of being told about MPLS based on problems it was trying to solve, even with old technologies, which is great for historical purposes, trying to understand some of the thought process behind how the protocols are built. But in reality, I'm not trying to learn all that stuff. It was going a little too slow for my taste. So what I did is I saw this reference in Brian McGann's video about this. Let me pull it onto the stream here. I need to remove that. Yes, another scene from The Last Jedi trailer, still on that kick. But this is MPLS configuration on Cisco iOS software in Safari Books Online. And this is great. It appears to me, and even Brian mentioned this in a video, the INE video, that it's kind of geared towards service provider, but that's what we're doing, right? With L3 VPNs and BGP and MPLS, essentially we're doing service provider type work. So this is really heavily geared towards service provider, but I want to go back, and I think this may be my new, at least for the rest of this particular section of the workbook, this may be my new reading resource. The MPLS fundamentals are just going way too slow for me. And it had a lot that really I didn't consider relative for what I'm trying to learn in the blueprint. Anyway, that being said, what's my next topic here? We've been talking about this is another thing that came up and has been brought up before on this channel. There's a link here for Kevin Wallace's CCIE time saver tips. He has some good suggestions here. Some of them are controversial, however. Some of them involve using aliases to speed up your lab. And again, Kevin Wallace, he's a better authority than I am. He has a great channel. He actually, I think he sells training materials and videos and other materials. And he has passed the CCIE twice. I think he has route switch and service provider. So take what I say with a grain of salt. Again, I'm just documenting my journey. I'm not trying to present myself as an authority on any of this. That being said, I have it on good authority that it's from a number of people who have passed. And again, this is this subject of using aliases in the lab, router preconfigurations to try to speed things up. This is a subject that is not gospel, right? It is open to interpretation and to each his own. But it's a very relative topic. It's not subjective. But he has some good suggestions, and I might try some of these. He talks about pre-configuring your routers and just opening up Notepad at the beginning of the lab and writing some of this out. That is linecon 0, exec-timeout 00, login synchronous. And he goes into the details of these in here. I may try some tonight. No IP domain lookup. Granted, yes, these will speed up this will speed things up. My only concern, and this has always been my concern with these types of questions or arguments, is could you inadvertently actually break something else that the script is going to be looking for when you get graded? Like maybe there are lab configurations about exec timeout and console lines or BTY lines. So that's my only concern about doing this kind of thing. And a lot of cases, it is strictly up to you, of course. But good video to watch to at least get you thinking about it. It's not just about router preconfigs. He has some other great suggestions there too. Not all of them I agree with myself. I'm not going to incorporate them into my approach, but you might. Then there's a good Catalyst versus NXOS trunks. This is from Net Craftsman. Really good real world experience that I took note of. It may come in handy for me one day. And then this RFC, which I've been reading. I've actually read a lot of it. This is in regards to what we're working on tonight, OSPF PE CE routing. Sham links, this is the RFC for that, 4577. So I have the link there. But let's get started on this lab. I've already done a good bit of work ahead of time on this lab. So I've loaded the topology. The topology in this case is specific to this lab, MPLS PE CE routing with OSPF. We've loaded that up. It is running. I've actually preloaded the requirements. So this is up, and standard disclaimer, this is an INE lab in the workbook. I'm just vlogging my journey and struggles. This is not a lab I designed. If you want to do the same lab, of course, you can purchase the workbook. It's $2.99, and it's linked here in the description of the video. I have the topology up for this lab. Let me show you folks what this is, and this is why I say this is evil. and this is partly a complaint. You know, I'm real good about complaining. I don't want to be a whiner on the stream. Nobody likes a whiner. But if INE is listening, or if they do listen, this is one suggestion I have for improvements of your workbook. The workbook here, this lab is supposed to introduce PE CE OSPF routing, which it does. It definitely does that. But it also introduced several very tricky, very mean things. Like, there are two labs for OSPF CE routing in the workbook. This one, and another one, which is a sham link. I think it's a great idea that they broke out sham link as a separate lab. I think some of the elements introduced in this lab would have also been merited their own separate lab. So and you'll see what I mean in a second when I talk about this, some of the requirements here. They could have done just a regular PE CE routing to introduce us to and familiarize us with the concept. But instead, they did that and jammed in several very complex components to doing this. And I'll show you what I mean. First of all, if you look at this, we have a simple router 6 and router 7. Router 7 in this case is going to be CE. Router 6 is going to be PE. We have our MPLS cloud, which is router 6, 4, and 5. So this is our label switched. This is our label switching routers. Then you have router 5 that is going to be in VRF VPN_A, and it is going to be PE router with router 8, which is going to be the CE router in OSPF. Router 10 is not in there, but you know, anyway, you get the idea. So the purpose of this lab is to introduce us to PE CE routing through MPLS Cloud. So we'll have router 7 should receive routes originated by router 8 in this OSPF area. A couple things you could probably see right away that are wicked crazy, that I'm not going to guarantee you'll never see them in production, but I mean, I don't see how anyone in their right mind would configure OSPF this way. This could be my lack of knowledge or experience. But look at this. There is no OSPF area 0. So they have introduced here OSPF area 1 and an OSPF area 1 here. So they're going to have router 8 running OSPF and no OSPF 0 or backbone area defined. Problem number 1. What I saw in the video is that oftentimes you may see area 0 and area 0 here. So your PE router will have a link in area 0 on both sides. And then the MPLS cloud becomes the super backbone. Or you would have OSPF area, a non-backbone area here and here, but they would be connected to an OSPF 0. Might be another case, right? These would be connected together to an OSPF area 0, even less common. But typically, from what I've understand from the video, is you'll have OSPF area 0 here in many cases. No, that's not what they want to introduce us here to the lab. So what you have to figure out is, what I have to figure out is how will LSAs be, when this is redistributed into BGP and from BGP back into OSPF, what LSA types will be injected into this OSPF area? I have my theories. I'm going to discuss those in a minute, but this is the requirements of this lab. The other, for fun, requirement, or the other oddball thing thrown in here, is that they want router 8 to have a new loopback, for that to be redistributed into OSPF or advertised. I'm not sure. They don't even say, really, but what they say here is that router 7 should see this as a summary. Well, we already know that OSPF summarization is tricky because you have an area command, you have an area summary, and then you have another summary address command. So not only do you have to know what LSA types we're looking at going back and forth in and out of the cloud, that's going to really determine how you need to summarize this route. On top of that, you're going to go from an area 1 here into an area 1 over here, and there's no backbone. How complicated is that? Very, I would say. So I'm going to take a stab at it. I'm going to read off the requirements here. So PE and CE routers are going to have an OSPF adjacency into area 1, unless I'm missing something. I very well could be missing something. Let's look at the current config, the running configuration in this topology. Maybe there's already an OSPF area 0 here. Let's look. Let's look on router 7. Show IP protocol section OSPF. I learned that command. Okay, nothing there. Just making sure. Now there's RIP here. RIP is running for some odd reason. Okay, routers 7, 3, and 9 are connected. 7, 3, and 9. Okay, wow. Now this is even more interesting. So RIP is running here. I don't think we're going to worry about that. Let's look on this other side here, router 8. Let's see what router 8 is doing. Jeez, this is really... This is madness. Absolute madness. Yeah, nothing running over here. I'm going to ignore the fact that RIP is running over here. I don't care about that. I don't know why it's there. Let's just say I'm a consultant on this job and I've been given very specific tasks to perform. So there's no other OSPF running here, we know that. So there's no OSPF area 0, there's no OSPF backbone in the IGP space. It says router 5 and 6 should use the same process ID. Yeah, I would think so. You want these areas to see each other as area 1. Even though these, as we know, with the super backbone, this becomes a hierarchical backbone. Even though these have the same area numbers, they should be treated as distinct areas. I think in this case, the fact that this is area 1 and this is area 1 is arbitrary. I believe if you had an area 0, technically speaking, and I've heard this in the Network Collective OSPF show, where they had a configuration with a single area 0, an actual area 0, not just the super backbone, but a backbone area. And they had scores of other routers connected to it, all as area 1s. So again, I think this is arbitrary. The fact that they're non-backbone areas, but they have the same number, I don't think that matters. So we're not going to worry about that. But they should have the same process ID so that BGP VPN knows that they're going from one area to the other and that they are the same areas. By the time we're done, we should have reachability between router 7 and 8. CE routers should see OSPF. Oh, this is interesting. The CE router should see OSPF external routes. Now, my understanding is that if you connect two areas and they have through an MPLS super backbone and they have the same area IDs, that they will come in as inter-area routes, LSA type 3s. This is saying, though, that they should see them as LSA type 5s, external routes. Let me double check the requirements here. CE routers should see OSPF routes as external. Use the same OSPF process ID on router 5 and 6, but ensure that our 7 and router 8 can reach each other. CE routers should see OSPF routes as external. So in this case, I believe what we need to do, according to what I read in this RFC, we will need to change the, there's a term for this. I'm going to try to find it. It's called the, this is a really good RFC, by the way. You almost have to read through it to really see the detail of what's going on. Domain identifier. If two, and here's OSPF domain identifiers. Each OSPF instance must be associated with one or more domain identifiers. Must be configurable. And the default value, if none is configured, should be null. If an OSPF instance has multiple domain identifiers, one of these is considered as its primary domain identifier. This must be determinable. If a route is installed in the VR by a particular OSPF instance, the primary domain identifier of that is considered the route's domain identifier. If R is distributed to R2, R will be as an AS external route, no matter what its OSPF route type is. It may be then, and we'll try this later. I think in the beginning, we won't try to change this identifier. We'll leave it alone. And I think these are going to come in as OSPF inter-area routes, LSA type 3s. If that's the case, then that means I'm going to have to change the domain identifier. And I saw this done on the video. All right, let's see. So I think we'll go to here first. Then check-in point. We'll see where we are. Make these changes, and then we'll do a check-in point here. Yeah, considerations. There is no area 0. We got to watch our process ID numbers and which method for the summary route. Since these are going to be external, then that means that BGP, that it's going to see these as ASBRs instead of ABRs. If that's the case, then we need to use, instead of an area range command, we'll use a summary route command, summary network. We're going to have to play this one by ear. I'm going to go learn as I go, basically. I'm going to try to do this from memory. I may not get very far. In that case, what I'll do is just pop up a configuration guide, if there is one. We're coming in raw, folks. All right, here's our configs file. And let's see where we go. So what I'll do here first, and I'm probably going to have to fill this out, so probably just going to have to, I may not be able to use a config file yet. This is router 5. He is here. Let's do router 6 first. And what we want to do, and router 6, of course, will be the PE router. So even easier would really be to do router 7. Yeah, let's do router 7. All right. And in this case, now it says we need to use the same process ID. That's locally significant usually. Like here, I'm going to say router OSPF 1. And we're just going to put all our networks in here. Network 0.0.0.0. Area 1. Router link states area 1. We just have 1. Link count is 4. Okay. Show IP OSPF database router. Yeah, and here are other links that will be included. So good. Easy enough. Now let's go to, that's the CE router, router 7. Next we go to the PE, provider edge, router 6. And we're going to say, in this case, we do router OSPF. Now there's a couple ways that I understood we could do this. By the way, we have to match the process ID. So router OSPF 1, that process VRF underscore. Now first I need to check my VRFs. Okay, VPN A is GI0167, which is this one, which is good. That's one that needs to be in VRFA. So we're going to say router OSPF 1. Let's do something different. And I'm going to go ahead and type this one out because we're going to reuse this. Router OSPF 1 VRF VPN underscore A. And we're going to put for our network is going to be just this show IPVRF, just this link. This is the only link we're concerned about. GI wants show IP and VRF VPN A. How do I do IP interface? Show IP interface brief. Well, in this case, that's fine. 151.67, right? So network 151.670. And this is going to be also area 1. It's going to be in the same area. And I believe that's all we have to do there. So then we should get an adjacency. VRF does not match existing router. Router OSPF 1. Router OSPF 1 VRF. VRF specified does not match existing router. Okay. Router OSPF. Oh, I wanted to make a different area, didn't I? Router instance number. Let's make it customer. Yeah, he talked about there is. Yeah, address family. There we go. IPv4. No. That's for multicast. Yeah, I'm probably gonna have to look at this. Router, OSPF. Did he do it at the interface level? Interface jazz 0167. OSPF. Yeah, shoot, I don't remember. I'm gonna have to look it up, guys. Let's go to the docs. Cisco docs. So this is gonna be configuration guides, IP routing. I want to say MPLS. Multi-protocol label switching configuration guide. And is it under L3 VPNs? Here we go. OSPF PE CE support. Router OSPF 1 VRF name network. Well, that's what I thought. Oh, is it already running? RIP is running. BGP is running. Oh, it is running already. Show run. That's right, because it is running. That's our IGP in. Duh. This is our IGP here running in the MPLS cloud. Okay. Well, obviously, we can't use that. So apparently, we need to use a different process ID. That's probably my issue. Yeah. So we're going to say process 15. In fact, I had it here. I don't know why I didn't use it. Router OSPF 15 VRF VPN underscore A. There we go. And then network. Boom. Now it says, do we have to do the address family? Address family. No. Not here anyway. That's if you're not using VRF mode. And we did not have a unicast option here. So label, we're going to redistribute BGP. In fact, we could probably go ahead and do that now. Let's go ahead and do that. Redistribute BGP. And let's do, actually we have to show. Let's check this. Here we go, configuring, here's an example. We probably need redistribute metric type 1 subnets. Yeah, network area, blah, blah, blah. Yeah, here's where we want to do the redistribute OSPF. So we need to do this as well under BGP. Show run section BGP. BGP 100. Sync community extended. Okay, here's this section. So we want to go in here. No, I want this. Yeah. Router BGP 100. Address family IPv4 VRF VPN underscore A. Redistribute. And we want to do redistribute OSPF. Redistribute OSPF. And this is going to be 15. And I'm just going to leave that there. I'm not going to put any other parameters. No auto summary, just by habit. And then exit address family. And we need to redistribute here as well. Yeah, redistribute BGP 100. Metric type 1. Subnets. I think I'm just going to do subnets here. All right, so we need to put this in OSPF as well. I'm going to type it in just for better practice. Router OSPF 15 VRF VPN underscore A. Redistribute BGP 100 subnets. So we have a lot of options here, right? Metric type, exterior metric type for redistributed, right. Is it going to be E1 or E2s? NSSA only, route map subnets tag. Good. All right. That's what we want there. Then under router BGP 100, address family IPv4, VRF VPN underscore A, redistribute OSPF 15, match redistribution of OSPF routes, metric for route map reference. Yeah, okay. No auto summary and exit address family. All right, that's basically what we need to do there, I believe. And do we have adjacency now on between router 7 and 6? Show IP OSPF neighbor. We do not. Let's make sure we have layer 2. So Show IP interface brief. Ping 151.67.6. Or is it 76 dot? Okay, we don't even have, well, that's why we're not going to have an OSPF adjacency. Show CDP neighbor. Well, this is not going to work with the sub interfaces in this particular environment. Show IP interface brief. Show run, show IP VRF. Okay, JES0167. So ping VRF VPN A. Why do we not? Okay, we have reachability there. Should be 67.6. That's odd. Source. Valid source address. Show run interface JES0167. Okay. Okay, this is the same problem as yesterday. INE, if you're going to have me configure this another in the INE complaint department, I repeated this complaint Monday, same lab, same scenario. Took me longer that time. But if you're going to have a lab topology set up where this is a CE router, please do not put VRFs on there as default. Thank you very much. That's the problem here. So let's do this. Sloppy INE, sloppy. Actually, we need to do no IP forwarding. No forwarding. Okay. Interface JES0167. Oh, what am I missing here? Show. Do show run interface JES0167. All right. Interface JES0167. Didn't I do no? No. IP. VRF. Forwarding. Okay. Stubborn, man. Stubborn. We didn't want that in there. Hello? All right, let's try this a third time. There we go. Now we should have an adjacency. Yes, and we do. Loading done. Good. All right, we've got PE to CE, 5 and 6. Do the same, or I should say 6 and 7. Let's do the same over here between routers 7 and 8. No, sorry. 5 and 8. So here we go, router 5. Let's do 8 first. CE router, easier. Let's check our interfaces here. Show IPVRF. Okay, no trash over here. Garbage, garbage. So router OSPF 1, network 000. Actually, it's pretty specific over here. Not really. Not on this side. Network 000. Area 1. And then we will go over here to router 5. Okay, it wants us to use This is hateful, guys. This is just hateful, all right? I think. No, that's right. Okay. I thought you were really screwing with me here, but we're good. Show IP VRF. Okay, 58 says it's in VPN B. Here it says we need it in VPN A. So, show run interface GI0 158. All right, so we're going to redo this. And we're going to say no here. And we're going to put it in VPN underscore A. And everyone's happy. Good to go. Now we need to put OSPF over here. So in this case, it is going to be 58.0. Redistribute Bgp 100 subnets. And all this will be the same. We're going to practice though. Router OSPF 15, VRF VPN underscore A, network 151.58.0, area 1, redistribute BGP 100 subnets, router BGP 100, address family IPv4, VRF VPN underscore A, redistribute OSPF 15, no auto summary. Don't even have the option here. We don't need that under BGP. Not sure why I have that. Okay. So now we should have adjacency. Show IP OSPF. Show IP VRF. How to do show IP OSPF interfaces? Or no, show IP OSPF neighbors. Oh, process number 15. Nice, we have full DR. All right, show IP route VRF VPN underscore A OSPF. Nice. Okay, so the real kicker is going to be, what does this look like? We should have, let's walk the packet here. We should have router 8 peered, neighbored with router 5 VRF VPN underscore A. Advertising routes. Router 5 should be taking these OSPF routes, redistributing them into BGP VPN v4, which will then be sending them to router 4 as a route reflector, iBGP route reflector. Router 4 will then advertise those prefixes to router 6. And router 6 will receive those routes in the iBGP process and redistribute those using the community or extended community attributes and inject those into area 1 OSPF process number 15. And then router 6 will then flood those new LSAs, which should be LSA type 3s, to router 7. So let's see if router 7, let's start at the end. Let's see if router 7 has an OSPF type 3 or 5 for this particular link right here. Let's say, well, let's pick, yeah, 151.1.0.80. Show IP route OSPF. And it does. And it is inter area. Okay. That's what I expected. So we're good here. We should have reachability as well. If I trace route 151.108.8 source Let's source it from 151.67.7. There we see. So we see we have reachability, and it is going through the MPLS cloud, 2 hops, and we're reaching router 8, which is great. So we've accomplished this much. So we've checked in here, we're good. Now, how do we get the CE routers to see these OSPF routes as external? One requirement is that these share the same process ID number, which is essentially telling the PE routers that this is the same, these are the same areas. I think what we have to do is manipulate this domain identifier. And if we look at our RFC, I'm kind of going in a loop here. I'm clicking. Yeah, this is if the OSPFs of an ISP are given one or more non-null domain identifiers. This procedure allows us to determine whether a particular OSPF originated VPN IP route belongs to the same domain as a given OSPF instance. We can then determine whether the route should be redistributed to that OSPF as an inter-area, which is doing now, or as an OSPF AS external route. The rules is the OSPF domain identifier carried by the route is compared with the OSPF domain identifier extended, which has been configured. All 8 bytes must be compared. Thus, 2 OSPF domain identifier extended community attributes are regarded as equal if and only if one of the following 3 conditions holds. They're identical in all 8 bytes. They're identical in their lower order 6 bytes value, but one attribute has 2 higher order bits of 05, and the other 2 has 2 higher order bits of 8005. This condition is for backward compatibility. The lower 6 order bytes of both attributes consist entirely of zeros. Now, how do you change this identifier? I saw this on a video. Let's go to router 6. Router OSPF 15, VRF VPN underscore A. And I think it's this domain ID. Domain ID. Yeah. Let's see if we can see what it is. Show IP protocols section OSPF. I think we could see it here. Show, now how do you do this for a particular, this is the global. Show IP VRF VPN underscore A protocols. No. Can I do show IP protocols? There we go, VRF. Here we go. That doesn't show us summary. Oh, that's cool. Summary. I didn't know about that. Of course, we can see it in the packet. Show IP OSPF. Show IP VRF VPN underscore A OSPF. No. Gosh, I never know when to put VRF. Show IP VRF. Show IP OSPF 15. Okay, that's what I have to do. Summary address timers, topology info. Maybe it's here. Okay, domain ID type is 05 and the value is 15. Okay, it said we had to use the same process ID. It does not say we have to use the same value. So I'm going to change this value to something else. That's what we need to do. Router OSPF 15 VRF VPN underscore A. And then domain ID. Is that what we just saw? The domain ID was something else, I think. It's interesting when you have compatible with commands, compatible with RFCs in your show command. It's cool though. It does say connected to MPLS VPN super backbone. It is an area border and autonomous system boundary router. Interesting. Redistributing turnaround. So there's a lot of information here. And we missed our information. Oh, here it is, right here at the top. Domain ID type and domain ID value. I think I can set both of those. Yeah, domain ID type. We're not going to change that. We're going to change the value, 0.0.0.30. Okay. I believe what that will do now is change these routes when they're coming in, and let's clear the process. Clear IP route VRF VPN underscore A star. Let's do it on the other side as well. That's 6. Let's do it on router 5. Clear IP OSPF VRF VPN underscore A star. Clear IP route, sorry. Route VRF VPN underscore A star. Now let's look on router 7. Show IP route OSPF. Ah, that did it. Now look at these routes. They're seen as external. So I've been hard on you. I have. But your video for this was actually pretty good. I have to say. Your video was pretty good. You didn't really explain about areas having no area 0. Obviously, we have a super backbone. But you kind of threw that wrench in there. But, you know, we figured it out thanks to your video. So I'll give you props on that. Now let's look at show IP route OSPF. And their OE2. We could change that, of course. We saw how to change that here. Metric type. But we could change that to 1 or 2. It is 2 right now, OE2, but that's what we want. So we're good. Okay, so this part is done. Check. That part is done. Now, here's the third cruel, horrendous part of this. It already wasn't complicated enough. Now we have to do interface L100, IP address 172.16.8.8, 205.205.0.0. Yeah, it has a /24. No shut. We know it's already up, but anyway. And is that should be included in OSPF because show run section OSPF. Because I think we did network 0000. Yeah. All right. So router, the upstream router should have that as an OSPF route. Show IP route VRF underscore A OSPF. And there it is, 172.16.8.8/32. Now, why is that? One 172.16 is variably subnetted. 3 subnets. Where the heck are the 3 subnets? And this is showing, this is so confusing, right? Like this is a /24. Am I doing no auto summary? It's not even an option. Yeah, it's not even an option. All right, I'm not going to pretend to understand that right now. I'm just going to move on. Sometimes you hit something in the lab you don't understand. You just move on. Doesn't make sense? It's okay. Humans wrote this stuff, right? Can I reach it? Ping 172.16.8.8 VRF VPN_A. See, sometimes you put the VRF after an option. Sometimes you put it before. It was encouraging to see Brian McGann on the video making this mistake as well. So I feel I'm not alone. If he does it, hey, I'm for sure going to do it. All right, so we have reachability. That's all we're going to summarize it anyway. So who cares? But router 7 should see this as a summary address. The question is, could we get away with doing this as an area range? Let's try it. I don't think that's the solution, but let's try it. So on router 5, router OSPF 15. That's global, isn't it? I'm trying to be cute here. Show run section OSPF. Okay. Router OSPF 15 VRF VPN_. I'm just going to get in the habit of putting the VRF there. All right. Area range. Do I have to do area 1? Yeah, range. 172.16.0.172.16.0.0 205.205.0.0. All right. Theoretically, the area range command is going to summarize. It's going to generate an LSA type 3. But since we're crossing the super backbone, let's see what happens. Let's clear IP route VRF VPN_A star. Let's do the same on router 6 and router 7. Show IP route OSPF. We're getting. So we're still getting this. We're still getting a /32, which how we got a /32? I have no idea. Oh, you know what? It might be from the network command. Show run interface L100 /24. Okay, well, it pulls it as a /32. But it appears that it is not hiding that part of the topology. Clear IP route star. Let's take the OSPF configuration out and put it back in. Show run section OSPF. Actually, that may be also here. Well, I cleared it here. Show IP route VRF BB_A OSPF. Yeah, we're not going to see, because of the redistribution, we're not going to see it here. I don't think. Yeah. So let's look back at router 7. No router OSPF 1. Router OSPF 1. Network 0000. All right, let's wait for LSAs to flood in. Loading to full. Show IP route OSPF. Yeah, we're still getting this, so the summary is not doing us any good. It sees a /16, but it also sees a /32. So this is not doing what we want. What if we need to do that on router 8? No, because you only do this on the ABR or the ASBR, and here a router 8 is not an ABR. All right, so that didn't work. So let's go back to plan B, which is to do a summary address. Router OSPF 15, no area 1 range. And we're going to do a summary address 192.16.0.0 205.205.0.0. Yeah. All right. Let's try that. Clear IP route VRF VPN_A star. Send router 6. And now let's see if on router 7. Okay, that show IP route was to 16.0.0. We only get the /32. Why the heck is that? And we still got 8.8. All right, well, I'm going to look at the, that is a, see, that's why this is so sneaky, man. You guys are evil. I need your evil. I've concluded. All right, I'm going to look at, I'm not going to battle this one too much because I picked my best guess. I did plan A and I did plan B and neither of them worked. So we're just going to look at the answer key and see how we did. Okay, so I'm going to pull these up here. This is what was in the answer key. Let's see how we did. Yeah, we did that. Router 5. And router OSPF, they chose 100. I chose 15. That's fine. Domain ID. Okay, they changed the domain ID here on router 5, and they changed it on router 6. I can respect that. I can respect that. Deterministic on both ends. So yeah, that's the better way to handle it because you want to be deterministic. You don't want to leave it up to chance. So I should have configured this on both sides. I only configured on one side, but I had the idea correct, and in a lab it probably would have flown. Redistribute Bgp 100 subnets network. They did everything network here. I chose a specific interface. Doesn't really matter. Either way, it works. Redistribute VRF. Redistribute OSPF 15. Now this seemed to work without. I don't think that's what I need to do different here. Yeah, I think we're fine there. And I see where my mistake is. I had the right idea. I had it in the wrong place. Had it in the wrong place. So I put it on router 5, when in reality it needed to go on router 6. Let's change it here. We don't need to do it. Well, yeah, let's take it out of here. Or out of router 5. Router OSPF 15. No summary address. Yeah, we got to put in the whole thing. And let's put it on router 6. Router OSPF 15. And under here, summary address. So this should inject. It's redistributing, and it's going to inject this summary address, LSA type 5, into router 7. So now let's take a look here. There we go, /16. All right. And okay, I see what you're doing here. It's saying doing capability VRF light, and it's leaving the VRF there. I think that's crap. I took off the VRF. There's no reason to have a VRF there. Okay. Yep, everything. All right. So I feel pretty good about that one. I will come back and review this lab for sure. What I want to see here, though, is I want to do a few packet captures. Just for grins, let's see what's coming in and out of router 6. So let's start a packet capture here. Actually, let's do router 6. So router 6, and we're going to pick Jazzer 1. Traffic capture. And I want a lot of stuff. I want LDP, I want... Just give me everything. And let's take this configuration out. And put it back in. Because I want to see the process. No router, OSPF 15, VRF, VPN underscore A. Yeah, and that's going to cause all sorts of havoc. That's fine. Now we're going to put it back. Router, OSPF 15, VRF, VPN underscore A. Network. They put everything in there. That's fine. Area 1. Redistribute BGP 100 subnets. I'm going to say domain ID is 0.0.0.6. And what else are we missing here? Yeah, we'll put the summary address in there as well. Summary address 192.16.00.25.25.00. All right. And let's take a look. Let's just play in the sandbox here, guys. Let's just jump in the sandbox and play around, see what we got. Curious George in the sandbox. Oh, ARP. All right, don't need to see ARPs, but that's okay. All right, so here, router 4, let's say, yeah, router 6, LDP hello message. And here is OSPF hello packet. 224.0.0.5, we know this would have been received by router 7. Area ID. Now look, this is interesting. We've got some things I'm not used to seeing in here. OSPF header, version 2. Hello packet. Source OSPF router. Area ID is backbone. Area ID is backbone. Really? Let me look back down here a little farther after everything's configured. LDP 224005 is what we're looking for, right? Let's filter on that. And let's go down to the last one we saw from router 6. Okay, yeah, here we go. OSPF header. Area ID is 0.0.0.1. When did that change? Link state update packet. All right. Oh, this is an acknowledge. Acknowledge. We want hello. There's a link state update, ls update packet. ls acknowledge. Yeah, 167.6. All right, here's the hello packet. Yeah, notice the area ID is 0.0.0.1. So it's area 1. Now, when did it change from 1 to 0? I didn't want to do that. 67.6. So our first... Okay, I was looking at the wrong thing, I guess. Yeah, the first hello packet is area 0001. Thought for sure I saw somebody saying he was 0. Okay, that could have been for the IGP in the provider network. That's probably what I was looking at, but now I'm curious. I want to go back and see it. LDP hello, OSPF hello. 0 backbone. Yeah, that's all right. That's IGP. That's OSPF running here. So, makes sense. Makes sense. What I want to see, though, is router 6. Yeah, he's going to send OSPF hellos this way to the VRF. And he's going to send them this way to the label switching router. Okay, 146.4. Yeah. Okay. Yeah, 146.6. He's also going to be backbone. But 160 or 67.6 is, of course, yeah, this is conversation between 6 and 7. So we've got hello, and then we've got a link state update. So we passed our phases for neighbor negotiation. And now we've got some LSA, and these are type 5s, right. So that's good. These are what are coming across the super backbone. And we should see, now let's look at those updates coming into router 6. That's going to be BGP. BGP updates from router 4, right? Yeah, so we've just got a few messages here. There's one update. And we should see inside of our... So we've got IP4, TCP. This is, yeah, BGP. And here's our path attributes. Oh, unreachable, NLRI. What is that? Multi-protocol unreach NLRI. Oh, withdrawn. I gotcha. This is a withdrawal. So this may have been when I changed the, I don't know. Withdraw none, update message to path attributes. Okay. Subaddress family, NLRI, BGP prefix, 5167.0. Oh, this is for sending to 6. Can we do IP proto equals BGP? No. Not sure how to filter on that. All right, let's find those BGP, VPN-v4 advertisements. BGP, those would be originating from 4.4, I thought. Yeah, these are the ones I saw, and then a keep alive message. I may have missed them. IP proto. I'm not sure why it's not allowing that, but okay, we got it sorted by protocol. That's what I should have done earlier. LDP, BGP. Okay, we've got 6 to 4 sending an update. That's fine. Let me see what you got. TCP, BGP update message. Unreachable, this withdrawing. Carried extended communities. Route target. Yeah, I want to see the... I know I probably didn't wait long enough. Let's change something here. Let's add a route and see it advertised. So let's say interface L100, IP address 7.7.7.7. Okay, that should be injected, and it should be advertised now from router 6. Let's see if we get it over here on router 8. Show IP route 7777. Has not arrived yet. We should increase the hello time, right? I'm missing some things here. I guess not. That is not making it over there. All right, let's look at router 4. Let's troubleshoot this. I'm sorry, router 7, yeah. Show, actually, let's look upstream. So router 6 should have a route for it. Show IP route VRF VPN_A OSPF. He does. 7.7.7.7. And he should be redistributing that. Did I not put that back in? Show run section BGP. Oh, maybe I left it out. That's why we're not seeing any BGP activity. Maybe? Ah, that's the problem. Come on, Quentin. Router BGP 100. No wonder we're not seeing those packets. Redistribute OSPF 15. Oh, address family. IPv4, VRF, VPN_A. Yeah. Now we should see those packets. Let's take a look. Let's make sure we get on router 8. There we go. All right. So I want to see what that looks like. I want to see that 7.7.7 packet. And it's going to be way, we got a lot of packets now. Should be way down here. Let's sort by protocol. Are we having fun yet, guys? I am. I actually like this stuff. I love this MPLS. These MPLS labs, they're more complex or more difficult, but they're much more enjoyable than a lot of what I've done in the past. All right, 4 to 6. This should be 6 to 4, sending a new update here. Actually, just probably have several in here. Path attributes. Okay, extended communities. Here's an NLRI, reachable. Where are you? Flags, path attributes. Where's the path? Where's the actual path, guys? Where's the NLRI? Update message. Address family identifier, IPv4. Oh, I thought this was secondary address family. It's subsequent address family identifier. Okay, good to know. Number of subnetwork points of attachments. Oh, here's the NLRI prefix. Okay, here's our summary. Nice. Wow, it's kind of buried down in there, isn't it? Prefix 15167. Okay, fine and good. Where's 7.7.7.7? Oh, here it is. All right. These all have the same attributes. Extended communities, flags. We should see all the, oh, here's the carried extended communities. There's 4. Here we have the route target. We're used to that. But here's the domain identifier. Yeah, good stuff. OSPF, the area, all this is carried in BGP as extended communities, and that is awesome. That is good stuff. Okay, I'm going to screen cap this. This is pretty good stuff here. Good stuff. That's what we wanted to see. Very juicy lab. It was cruel. She was a cruel lab, but she was a juicy lab. I liked it. All right, well, I think that's all we had for this evening, folks. Let's update our spreadsheet here on progress and look at what's next. I can already tell you what's next. I did not get to it tonight, but I want to get to this. Hopefully tomorrow night, and that will be OSPF Sham Link, the dreaded sham link should be coming up next. So this is getting pretty big, I guess that's why it takes a minute to load. But there it was. That was our, what's today, the 20th? So there's our PEC routing with OSPF lab. I've already watched the video for EIGRP, so depending on how long this one takes, OSPF sham link, this one will either be tomorrow or on the weekend. So anyway, looks like we are 52.71% done. July 10th is our current finish date. That keeps getting pushed back, but I'm perfectly fine with that. Well, folks, I think that is going to wrap up the LAN Tamer stream for tonight. Thanks for joining in, watching. You know, if you have not yet, follow me on Instagram, Facebook, Twitter, and especially Discord. We've got not many users in Discord right now. Discord is, we chat throughout the day, share ideas, share links, things like that. It's kind of a community tool. Definitely check it out. The links are in the bottom of the description. Please like this video and subscribe if you haven't already. And thanks again. Happy labbing. And we shall see you back here in the stream tomorrow night.